Hello, Bacho. How are you? I hope you all are good. Okay, so in previous class, in our acid bases and salts, we discuss bases. So in bases, we mainly discuss physical properties of bases, then chemical properties of bases. Okay, so now it's time to discuss some uses of bases here. What beta here? Some uses of bases. So see here uses of bases. So in uses of bases, very much so many important use of these bases. Suppose if you are considering here NaOH, okay. So this NaOH, it is used in the manufacturing of soaps, okay. It is used in the manufacturing of what beta? Soaps, okay. Then in the manufacturing of your textile, okay. Then in paper industry, where beta? In paper industries, okay. So these are different uses. So and one more here important use of your NaOH in petroleum refining, petroleum product, refining, okay. So very much important here whatever your NaOH, okay. So second, if you discuss NH4OH, so beta this NH4OH used in, okay, as a laboratory reagent. What beta? As a laboratory reagent, LR, laboratory reagent, and is used in the production of, okay, for making for in the production of fertilizers, rayon, plastics, okay. So many uses, and dyes also, in dyes, whatever colored dyes, okay, NH4OH is used. So we will discuss here third also. So third, if you are considering third, calcium hydroxide. So this one also very much important, okay. It is used in the production of cement, okay. Then your mortar and pestle, okay, that you know in Ayurved, mortar and pestle, okay. Then it is used in the manufacturing of bleaching powder, okay, bleaching powder, whatever your this calcium hydroxide is used in white washing, okay. In what? In whitewash, okay. And in the acidity of soils also, in acidity of soils, whatever your calcium hydroxide is used, okay. So these are different uses of your some of your NaOH, NH4OH, calcium hydroxide, and KOH also. So see here, fourth one, KOH. So this KOH, it is used in the manufacturing of soaps. It is used in the production of what? Not production. Whatever your KOH, it is used in batteries. Okay, storage batteries. Okay. Now next, suppose if you are considering here next, ALOH thrice. So beta this ALOH thrice, it is used in the fire extinguisher. Where beta? In foam fire extinguisher. Foam fire extinguisher. Okay, foam fire extinguisher. In that foaming agent is used as, Al2SO4 thrice. What beta? Aluminium sulfate foaming agent. Next beta here, 6-1, magnesium hydroxide. So this magnesium hydroxide, as you know, it is used in magnesium hydroxide. We can call it as a what in medical purpose. Okay, that is milk of magnesia. What beta? Milk of magnesia, or we can call it as a what, as an antacid. As an antacid. Okay. Next one, you are CaO, quicklime. So this quicklime as a drying agent also, as a what beta here, drying agent. Okay, then next it is used in the flux, basic flux in the extraction of metals. We discuss in our metals and non-metals, whatever your CaO, it is used as a basic flux in the extraction of metals. Okay, so these are what beta? Yes, these are your some important uses of bases, some important uses of bases. So see here, we will move towards next part of this content, say neutralization reaction. What did I hear? Neutralization reaction. So basically this neutralization reaction, okay, suppose if you are considering your neutralization reaction, or can be viewed along with whatever your H plus and OH minus sign. Okay, so neutralization reaction, as you know, acid and bases. So acid, as you know, acids what they are giving, they are giving a proton, that is H plus, and base they are producing what, OH minus in their aqueous solution. Okay, so these are what, suppose if you can view along with their H plus and OH minus. So these also what examples of neutralization reaction. So as you know, your general reaction, that is HCl and NaOH, that gives what, NaCl plus water. Okay, this reaction, you are familiar with this reaction, HCl plus NaOH, acid and base, that gives what beta? Yes, NaCl plus water plus heat, plus what beta? Heat. Or we can write in this fashion, H plus in aqueous solution plus OH minus in aqueous solution. Okay, what they are giving us? Yes, water, H2O liquid plus what beta? Heat. Means basically these are exothermic reaction. What beta? Exothermic reaction. In that the amount of heat liberated depends on, whatever amount of heat liberated depends on concentration of H plus and concentration of OH minus ion. Okay, produced by dissociation of acid or we can say base. Okay, so here one of the important note regarding your neutralization reaction you have to keep in mind, basically it is for your higher standard. So here important note we can say as a extra point. Okay, so see this, whatever your important note you have to keep in mind. Obviously it will come in your higher standard. Heat of neutralization of, so see here, heat, we can say just first small rotation, small Roman notation. Heat of neutralization of strong acid, strong acid and strong base. Okay, so heat of neutralization of strong acid and strong base having a some constant value, experimentally some constant value, so that you have to keep in mind. Okay, so that is that fixed value. So see here, heat of neutralization of strong acid and strong base having a fixed value. So see that fixed value. Okay, minus 57, minus 57 kilojoule, kilojoule per mole, or in kilocalorie also we can write, that is minus 13.7 kilocalorie per mole, kilocalorie per mole. Okay, so beta here whatever this negative sign indicates, what indicates that heat release during a neutralization of reaction, heat release during a neutralization of reaction. So see, plus heat, these are what, neutralization reaction. These are first case here. Okay, so what is the second case regarding your heat of neutralization of strong acid and strong base we saw. So regarding your heat of neutralization for weak acid and weak base, so say heat of neutralization of, heat of neutralization of strong, sorry, weak acid, we have to work on what, weak acids, weak acids and weak bases. So this value is less than your minus 57 kilojoule per mole or minus 13.7, okay, minus 13.7 kilocalorie per mole. It is less than. So why it is less than? Because what will happen here, some amount of heat, because some amount of heat is utilized in the dissociation of weak component. Some amount of heat is utilized in the what, in the dissociation of weak component. So as you know, basically your weak acids, they are dissolve or they are ionized in less extent as compared to strong acid and strong bases. So some amount of heat they utilize to dissolve in that in particular solution. Okay, so that's why here what, less than minus 57.0 kilojoule per mole or minus 13.7 kilocalorie per mole. Okay, so these are, obviously it will come in your higher standard. So this value, okay, most important, very much important. Okay, so we will move towards next, that is some uses of neutralization reaction. Okay, so say uses of neutralization reaction, we will see here. Uses of neutralization reaction. So as you know, neutralization product is what? Yes, salt plus water. So suppose if you are uses of neutralization, first we will say here slag lime. Slag lime. So beta, slag lime is what? Yes, calcium hydroxide. Calcium hydroxide. Okay, it is used to reduce. It is used to reduce. Yes, now only we discuss this. Acidity. Yes, acidity of soil. It is used to reduce acidity of soil. Then second, as you know, antacids. Okay, neutralization reaction, what they use is antacids. Say here, antacids tablets. As you know, antacid tablets is what? It contain magnesium hydroxide. It is used to treat what? It is used to treat excess, whatever excess of HCl it is produced in our stomach. With the help of MgOH twice, we can neutralize that acid. Okay, as you know, we are saying acidity. Okay, so then either we have to take these antacid tablets or some syrups also. Okay, for example, as you know, with the brand name Gelusil, okay, Digene, these are what, some syrups for to reduce acidity in stomach, to neutralize that. Okay, so next we will discuss here whatever third uses of neutralization reaction, stings. Okay, or ant, as you know, stings of ants or bees, stings of ants, or we can say what, bees, contains formic acid. Okay, what beta contains formic acid is what? HCOOH, formic acid neutralized can be neutralized by rubbing soap. Yes, by rubbing soap. So how it can neutralize by rubbing soap? Because whatever stings, with the help of stings, your ants they are producing what? HCOH, formic acid. It can be neutralized by rubbing soap. So already soap means what? In that soap, your bases, alkalis are present, so it can neutralize easily. Understood? And most important, that is uses of neutralization. Okay, lithium hydroxide. What beta? Lithium hydroxide. So that lithium hydroxide, LiOH, okay, it is this base, it used to neutralize CO2. It is used to neutralize CO2 exhaled by astronauts in spaceship, where in spaceships. Okay, so these are very much important uses of neutralization reaction. Understood? So you have to keep in mind whatever each and every sentence you have to write in your notebook as a notes. Okay. Now one thing you have to remember regarding acids and bases. Okay, so that one thing is what? Whenever we are uh, diluting acids or diluting base, okay, we suppose if you are preparing solution. So see here, which method you have to use to prepare these such type of solutions. Okay, so say for example, it is what your beaker. Okay, it is another beaker. It is what beta? Another beaker. Okay, so what will happen? What care should be taken during addition of acid or bases in water? So very much important. So basically, whenever when you are adding acid or bases, so it is in water. It is what basically highly exothermic reaction. Okay, what beta? It is highly exothermic reaction. That's why we have to, whatever your acids and base, we have to add in water with a constant stirring. Okay, this is what beta here. Suppose if you keep here stirrer, this what stirrer. Okay, this what here beaker, and here what beta base of beaker. Okay, now say here to your base of beaker. Okay, now see what will happen, what care should be taken during addition of acid or bases in water. These are what beta here stirrer. Okay, here also what is stirrer. Now say after addition of water, so see adding acid or base drop by drop. Suppose in this beaker here what beta? Water. Here what? Water. Okay, so whenever we are to add acid or bases, okay, whenever we have to add what? Acid or bases, so see adding of acid or bases, adding of acid or bases. Okay, so basically I told these are what? Highly exothermic reactions. Adding of acid or bases drop by drop. What beta? Drop by drop. Okay, so this method, it's correct method. Why this method is correct? Because basically your this water, okay, here what beta? Water. If you adding here, if you are adding acid into that water with constant stirring, it will not produce that much heat. Okay, and if you are considering, suppose here what, it contain your either acid or bases in another beaker, acid or bases. These are what totally wrong here. Whatever here this process is totally wrong, because it gives what, some explosion. Okay, it gives what, that's why you keep in mind water is never mixed in acid or bases. Okay, so we can observe here like this, whatever your this water. Never mix this water in your acid and base directly. It is highly exothermic reaction. What? Highly exothermic reaction. Okay. So this one thing here you have to remember. Okay. Whenever you have to dilute acid or bases. Okay. Now we will discuss here. Okay. Now what we have to discuss? Next part. In indicator already I told I prepare one practical video also for that for your methyl orange, then phenolphthalein, then blue strips, blue litmus strip, red litmus strip. Okay, so see here we will move towards our next part, that is strength of acids and bases. Okay, what beta? Strength of acids and bases. So how we can identify, say, strength of acids and bases? So very much important, this part, strength of acids and bases. Okay, so whatever the strength of acids and bases we can measure with the help of pH scale. What beta? With the help of pH scale. So see here you have to write like this, pH. Okay, so this basically pH means what? pH is potential of hydrogen. Okay, in German pH means potential or potence of what? Yes, hydrogen. Okay, means whatever your power of hydrogen and the strength of acid and base, it depends on concentration of H plus and OH minus ion. Whatever strength of your acids and bases depends on concentration of H plus and OH minus ions. Okay, so it is a what scale for measuring concentration of what? Hydrogen ion. Okay, H plus ion concentration, or we can say, okay, suppose if you are thinking about H plus ion concentration, so for H plus ion concentration, this pH is we call it as the what? pH. But whenever we are discussing for concentration of OH minus ion, so that OH minus ion is called as what? POH. Simply what beta? POH. So for pure water or for neutral solution at 25 degrees Celsius, okay, the concentration of H plus, so say at 25 degrees Celsius, concentration of H plus ions is, how much? Yes, here like we have to write in this fashion, concentration of H plus 10 raised to minus 7 mole per liter, or we can write mole liter inverse. What beta? Mole liter inverse. So same as like a concentration of OH minus also, concentration of OH minus ion, we can write like this, concentration of OH minus ion how much? Yes, 10 raised to minus 7 mole, because for neutral solution is what? Concentration of H plus and concentration of OH minus, that is water. Okay, pH what will come? 7. So mole per liter or mole liter inverse. Okay, concentration is what? In terms of molarity. Means from this data what we conclude? Concentration of H plus is equal to concentration of OH minus ion. Okay, and together we can write like this. Okay, together we can write concentration of H plus into concentration of OH minus. How much? Yes, 10 raised to minus 14. 10 raised to minus 14. So this thing you have to keep in mind here. Very much important, this strength of acids and bases. Okay. Now it varies with temperature also. Means pH decreases with the increasing temperature. What beta? pH decreases with increasing temperature. Now we will discuss some here whatever pH scale. Okay, so concentrate on our next part also. Some pH scale, whatever here, 1 to 14 generally. Okay, so say carefully concentrate on this point. Okay, so say suppose if you are considering pH scale, so we have to write here first. Okay, say concentration of H plus. Okay, then here what beta? pH value. Here what? pH value beta. P we have to write like this, pH value, and here what? Yes, concentration of OH minus ion, concentration of H plus, concentration of OH minus ion. Okay, so concentration of H plus ions. So suppose we will draw here first whatever from pH 0 to what beta? Yes, 0 to 40. So say how we can draw here. Yes, say 0, then 1, 2, 3, 4, 5, 6, 7. Okay. Now next what beta here? Yes, 10 pH value, 9, 10, 11, 12, 13, and here what beta? 14. Now how concentration of H plus will vary? See here. Okay, that also we will write here. 10 is to 0 concentration in terms of 10 is to. So here what beta? 10 is to 1. Okay. Concentration. So because 1 upon H plus. So minus 1. Okay. So then what beta here? 10 is to minus 2. Here what? 10 is to minus 3. Here what? 10 is to minus 4. 10 is to minus 5. 10 is to minus 6. 10 is to minus 7. Because it is a negative, pH is equal to what beta? Negative logarithm of concentration of H plus ions. Okay, so see here 10 is to minus 8, 10 is to minus 9. Okay, so see here 10 is to minus 10, then 10 is to minus 11, 10 is to minus 12, 10 is to minus 13, 10 is to minus 14. Okay, so if you are considering here increasing concentration of H plus ion, what we can write from this to this? Yes, see, we can write here what? Increasing, yes, say increasing concentration of H plus ions. Understood? Now if you are writing regarding concentration of OH minus, so what will come here beta? Concentration of OH minus, yes, it is starting from what? 10 is to minus 14. Say 10 is to minus 14, then here what? 10 is to minus 13, minus 12, 10 is to minus 11, 10 is to minus 10, 10 is to minus 9, 10 is to minus 8. Yes, here obviously it will come 10 is to minus 7. Okay, means what? For neutral. These are for what? Neutral means concentration of H plus is equal to what? Concentration of OH minus ion. 10 is to minus 8. Okay. Then 10 is to minus 9. 10 is to minus. Okay. Sorry here. 10 is to minus 6. Decreasing. Decreasing concentration of H plus and increasing concentration of OH minus ion. So say minus 5 here. Then 4. Then what? 3. Minus 2, 10 is to minus 1, and here what? 10 is to 0. We can call, okay, what we can call here? Increasing concentration of OH minus ion. So see here, yes, increasing concentration of what? OH minus ions. Okay, so very much important here. Or we can write here acidic character increases and basic character increases. What vector also we can write here? Okay, what we can write? Yes, acidic character increases, and here what? Basic character increases. Understood? So these are what regarding your concentration of H plus and OH minus, how it will vary. Or here we can write beta whatever 10 is to minus 7, this we got. So this we got here means here concentration of H plus, okay, concentration of H plus into concentration of OH minus ion is what? This total 10 is to minus 14. Understood? Here neutral or water. Okay, understood this? So I prepare one video for your pH paper strip also. Okay, for practical. Understood? So here we call it as a what beta? Neutral. Here what? Neutral. Understood? Here what we call neutral. So here you have to keep in mind here concentration of H plus slowly moving towards your base, and here what? Concentration of OH minus first increase, then slowly decrease. Okay. These are what? Concentration of OH minus ions highest. Okay. Now we can move towards our next part. Okay. That is how your whatever concentration of H plus and OH minus for neutral, for acidic, and for basic. Okay, so that we will say. Always keep in mind here for neutral solution. Okay, for neutral solution, concentration of H plus is equal to what beta? Concentration of OH minus ion. For acidic solution, yes, concentration of H plus is greater than your concentration of OH minus ion. For basic solution, what will happen? Concentration of OH minus is greater than your concentration of H plus. So you have to keep in mind this all. Okay, regarding, or we can say mathematically whatever our pH. Okay, mathematically pH we can write here. Mathematically pH can be written as yes beta, pH is what? Negative logarithm of concentration of H plus ions. Okay, same if you are writing about POH. So POH is what? Negative logarithm of concentration of OH minus ion. Okay, this P means what? So from this data, one thing I think you observe here, P means what? P means negative log. P means what? Negative log. Okay. So these are our pH. So whatever next part we will discuss in our next lecture. I hope you understood this all content of today's lecture. If any doubt, you can send me on WhatsApp. Thank you.